This video goes over formulas homework 3. So we had several calculations that we needed to do last night for homework, and I'm just going to run through those here really quick. I have 0.30 moles of water, and I need to go from moles to grams. The way we go from moles to grams and grams to moles is through molar mass. So the molar mass of water, we have 2 hydrogens and 1 oxygen. From the periodic table, each hydrogen is 1.01 and oxygen is 16. That gives us a molar mass of 18.02 grams per mole. That means there are 18.02 grams of water in 1 mole of water. So that's what we're going to use here. Mole is here, but we don't want moles anymore. We want to cancel that out. So moles have to go here. And that lets us know which way to write this. 1 mole has to be on the bottom, and then 18.02 grams of water has to be on top. Moles cancel out, and all we're left with are grams of water, which is what we were looking for. And it's everything on top multiplied together, divided by everything on the bottom. I need 2 sig figs, so this is going to be 5.4 grams of water. All right, so that's using molar mass as a conversion factor. In number 2, we see the word molecules, and that lets us know we're going to have to use Avogadro's number somewhere, and that tells us there are this many molecules in 1 mole of anything. So I have the same number here, 0.30 moles of water, but now I want to figure out how many molecules. So instead of using molar mass, which will take me to grams, I'm going to use Avogadro's number, which will take me to molecules. Mole is here, mole has to go here, so it'll cancel out. And that lets me know that 1 mole has to be on the bottom, and 6.022 times 10 to the 23rd molecules has to be on top. Moles cancel out, and so we're left with our molecules, and it's everything on top multiplied together, divided by everything on the bottom. When you use Avogadro's number, it's very likely that your answer will be in scientific notation, and this is one of those cases. So make sure you look all the way to the end. So I got 1.8 times 10 to the 23rd molecules of water. All right, so that's using each of those conversion factors individually. In number 3, we have molecules, and we also see the word grams. So that lets us know we're going to have to use both Avogadro's number and molar mass. 23 molecules per mole. And I gave you in the problem the molar mass of this PCl3 as 137.32 grams of PCl3 equals 1 mole PCl3. Okay, so now we're going to start with the number they give us in the problem. So that's going to be 1.02 times 10 to the 23rd molecules of PCl3. Molecules are here, so molecules have to go here so that they will cancel out. That means I'm going to have to use Avogadro's number, so 6.022 times 10 to the 23rd molecules in 1 mole of water. Oh, nope, water, not water, PCl3. All right, molecules cancel out. And now we have moles of PCl3, but we don't want moles, we want grams. So now we're going to use molar mass to convert from moles to grams. Mole is here, mole has to go here. So that lets me know that I'm going to have to write this as 1 mole of PCl3 on the bottom and 137.32 grams of PCl3 on the top. Moles cancel out, and all we're left with are grams of PCl3. Everything on top multiplied together, divided by everything on the bottom multiplied together, and you should end up with that 23.3 grams of PCl3. Now I'm going to show you what that looks like on a calculator when I type this in. So it is 1.02 second, and then I'm going to hit this EE button here. And what do I have here? 23. Okay. Times 137.32 divided by 6.022 E23. And there's that answer there. All right. We can also do this on Desmos. Maybe. There we are. So I'm going to start with one. Whoops, I need to probably put parentheses. Let me go back. And let's put parentheses, which are, if I can get these off of here. Here we go. All right, so parentheses, and then we'll there over 1.02, and then times 10, a to the b, 23 times 137.32, end parentheses, then divided by 6.022, and then times 10, a to the b, 23. And so you see, I get the same answer that way too. All right. So then in number 4, we are trying to find the percent composition of copper 2 fluoride. So the first thing you want to do in percent composition is find the mass of the whole thing. So copper and fluorine, I have 1 copper and 2 fluorines. Each copper is 63.55 from the periodic table. Each fluorine is 19. I'm going to add those up together, and I end up with a total molar mass of 101.55 grams per mole. To find the percent copper, it's the mass of all the coppers over the mass of the whole thing. So the mass of the whole thing is 101.55, and the mass of all the coppers only have 1, so 63.55, and then times 100. That's going to give me 62.6%. And then the percent fluorine is going to be same number on the bottom, because that's the mass of the whole thing. And I've got 2 fluorines, so that's 38. 19 times 2. And that gives me 37.4% fluorine, and that's copper. So we had 2 answers for this one. All right, and then an empirical formula practice. Okay, so number 5 is calculating an empirical formula. So the little rhyme for that one is percent to mass, mass to mole, divide by small, multiply till whole. All right. Sorry about that. Okay, so then I've got 52.11% carbon, 13.14% hydrogen, and 34.75% oxygen. We're going to assume that we have 100 grams, so that will make things easier for us when we go to find the mass of each of these. So 52.11% of 100 is 52.11. So that's how many grams of carbon, grams of hydrogen, and 34.75 grams of oxygen. Now I'm going to I went percent to mass, now it's mass to mole. The molar mass of oxygen is 16 from the periodic table. The molar mass of hydrogen is 1.01. And the molar mass of carbon is 12.01. All right, so when I divide those, maintaining the correct number of sig figs, so I had 4 sig figs in my number, so I need to have 4 sig figs when I convert. And then this one, and then this one is 2.172 moles of oxygen. All right, so now I've gone percent to mass, mass to mole, divide by small. So the smallest number out of my moles here is this one. So I'm going to divide all of them by this number. And I get 5.99 when I do this, which is close enough to 6 to call it 6. And then this one is 1. And so my empirical formula, we don't have to do that last part of the rhyme, which is multiply to a whole. All of these are whole numbers. And so it is C2H6O. And that is the correct answer. Now, this is not on today's quiz, but these guys are. So make sure that you can use molar mass and calculate molar mass. Make sure you can use Avogadro's number in problems that say the word molecules. And make sure that you can do percent composition.